we have one more thing here, which is honestly probably my favorite. So before we do that, generally speaking, a midpoint is going to be our best approximation. Um, our midpoint is going to be our best approximation because of how just our graphs work. If our graph is strictly increasing or strictly decreasing, that midpoint is going to get that middle value. It'll get a little bit above and a little bit below our line, and hopefully we'll kind of even out. So midpoint is generally the best approximation between those three. But we have one more approximation. It is my all-time favorite approximation that we have here, and that is the trapezoidal approximation. So when we do a Riemann sum, we're using rectangles, but when we do a trapezoidal rule or a trapezoidal approximation, we're going to be using trapezoids. We like rectangles because they're easy to kind of deal with, but our trapezoid here is going to be taking an average of our heights and finding a height between those two. This is different than our midpoint because sometimes our heights on our ends, they could be the same, they might not be. So we're going to be looking at the average between the endpoint heights and then multiplying it by the base, and that's going to give us kind of our rule here. So the area of a trapezoid is 1/2 times height times our bases added together. We can write it in a slightly different way. This way just kind of gets rid of larger fractions in our problem. So one thing that we need to notice is just how these trapezoids are drawn. So a lot of times when we were learning about trapezoids, this is the trapezoid we would see. We have two bases. I'm going to call this one base 1, this one base 2, and then we would look at the height between those two bases. When we are dealing with trapezoids here, they're going to be looking a little bit different. They're going to look kind of like a rectangle where the sides are just not the same. So our rectangles are going to be looking more like this, where we have base 1, base 2, and our height. And that kind of is shown here in our problem. They're pretty close, but if we look here, that's still technically an overestimation, versus if I look here, that is going to be an underestimation. We just need to kind of be aware of what's going on and kind of looking at different places to kind of help us out decide what's an over and underestimation. So an amusement park opens its doors at 9 a.m. t equals 0. The rate that people enter the park at time t is modeled by the function p prime of t in thousands of people per hour. Selected values of p prime are given in the table above. Use the trapezoidal approximation with 3 subintervals indicated in the table to estimate the total number of people that have entered the park between 9 a.m. and 7 p.m. So, just like all the other ones, we can use a letter to kind of tell us what we're doing here. So, because it's trapezoidal rule, we're going to use T as our letter and then S sub 3. So, trapezoidal rule with 3 subintervals. So, 9 a.m. until 7. So, we have 9 to 12 is 3 hours, and then noon to 7 is another 7 hours. So one thing that we want to be careful here is this problem is only asking about between 0 and 10, not 0 and 14. So we want 3 subintervals. We're going to be using 0 to 2, 2 to 5, and 5 to 10. So we have 1, 2, and 3. Okay, so we need our formula here. So I'm going to start with 1/2 times. We want our height, which is going to be the distance between our x values. So the distance between 0 and 2 is 2. And then we're going to multiply it by the bases added together. Our bases are just our y values. So we have 7 plus 11. And then we repeat. So we have 1/2 times the distance between our x values, t values in this case, 2 and 5. And then we're going to multiply it by our y values added together. So 11 plus 8. And then our last one. 1/2 times the distance between 5 and 10 times those y values, 8 plus 4. There are ways that I can simplify this. I can pull out things they have in common. I have a 1/2 times everything. But I can also just write it out every time and then simplify as I go. When I do this, 1/2 times 2 times 7 plus 11 is 18. 1/2 times 3 times 11 plus 8 is 28.5. And 1/2 times 5 times 8 plus 4 happens to be 30. When I combine all of these together, I'm going to get 76.5. So between the hours of 9 a.m. and 7 p.m., we have 76.5, but this is in thousands. So we have 76,500 people that have entered the park. Okay. So I talked about over and under estimations. So one of the things that we have is these tables that kind of help us out. So over and under approximations, when we're talking about left and right, we're going to be looking at increasing versus decreasing. If our function is increasing, our left is going to be an under approximation, our right is going to be an over approximation. When we are decreasing, our left is going to be an over approximation, our right is going to be an under approximation, and our explanation for those are literally going to be because our function is increasing or decreasing. On the other hand, when we look at midpoint and trapezoidal rule, we want to look at the concavity of our function. If we have a midpoint function and our concavity is positive, then we are going to have an under approximation. If we're looking at trapezoidal rule and our concavity is positive, we are looking at an overestimation. And just like with left and rights, with increasing and decreasing, they flip. So if we have a midpoint Riemann sum and we have a concave down function, our concavity is negative, it's going to be an overestimation versus a trapezoidal rule where our estimation is going to be an underestimation. And it all has to do with what our functions look like. If I have a function that is concave down, and I'm looking at trapezoidal rule, I'm going to be picking endpoints, and that distance between our endpoints is going to be under. Whereas if I'm looking at midpoint, I'm looking at the difference between these two, say here, and it might be over one of these. It's going to be really obvious when we are looking at a parabola and you look at the maximum. Versus if we're looking at a concave up function, our trapezoidal rule takes our endpoints and connects them being just a little bit over. Our midpoint function will take our endpoints, find the one in the middle, and then make a line. Sometimes it gets over, sometimes it gets under, but when we look at the fine details, overall, it's going to be underestimated. So when we look at these, our estimations, we can tell if they're under or over based off of what's going on with our graph using that Unit 5 knowledge to kind of help us out here.